Charbel, Alejandro. My name is Victor, and today we're going to be presenting our project, the solar powered steam engine. Some of the issues we're trying to address with this project is the growing demand for green energy worldwide. Also, the fact that many developing areas don't have access to centralized power grids due to their low population density and they're far distant from each other in some developing countries. And the disturbing fact that power generation is the single largest source of U.S. global warming emissions. The motivations behind the project is to help out with the small power needs of about 750,000 Americans living off the grid as of today. Renew interest in the steam power generation since it's been overshadowed by the burning of fossil fuels decades ago. And to overall help lower carbon footprint of humanity. The main objective of the project is to develop a hyperbolic solar collector that will harvest enough thermal power to create a steady flow of steam. A secondary objective will be to implement the system that will utilize the steam to create rotational energy and in turn can produce electricity. The scope of the project is the solar collector while taking into consideration the other major components, which are the water tank, the condenser, the water pump, and the steam engine. This is what the final prototype layer could look like. Again, our focus is on the innovative solar collector design and the implementation of the other major components into the system. Now I'm going to pass it over to
Okay, so for the proposed design for a solar collector, we want to emphasize in utilizing all three major methods of heat transfer in order to maximize our heat production. Those three methods, as we all know, is conduction, convection, and radiation. Now, we also want to induce creating a greenhouse effect in order to complement the heat production and keep the system at an internal higher temperature than the ambient. And lastly, we want to maximize the surface area, and after doing some research, we managed to narrow it down to using a hyperbolic geometry, as you can see in the picture. Now, for our design specifications, we went with some materials, and we've included that using copper is our best choice due to its high thermal conductivity, low pricing, and ease of manufacturing. Secondly, we were able to run some preliminary simulation using the load from the thermal sun, which is 1,000 watts per meter square. As you can see, just to show the temperature distribution across our systems and to have an idea of how it's going to behave. Now, for the global components, one of the most important facts is that we want to make sure that the prototype is able to be used anywhere in the world as long as you have sun and water. We want to be able to fulfill some of the small power needs of people that are in remote areas or developing countries. We're also focusing on the inexpensive materials, making it easy for anyone to be able to acquire the materials and build it themselves, and that's the reason why we want to make it as easy as possible to manufacture. Now I'm going to pass it over to Charbel.
In the process of our project organization, we came out with a series of challenging aspects that we thought might arise in the future. The first one is finding the ideal flow rate to generate steady steam pressure. We don't want to pump too much water into the solar collector and not be able to evaporate it. Calculator requires few parameters and the integration of the generated steam into the engine. For the cost analysis, we did some research and we estimate the price of our solar collector. It came out to be $285. This is a completely rough estimation. We believe as we go further into the project, we're going to have a slight increase in price. This is the timeline. As you can see, we still have to work many tasks in our project. We believe that the construction and the testing will take us the most time. For the responsibility, this is the breakdown responsibilities for our group. We try to divide it as evenly as possible, so each member can have the same opportunity to work in the project. And in conclusion, it's an innovative solar collector as an effective way to harvest thermal energy, independence of fossil fuel, and is environmentally friendly. We want to thank Dr. Chamante for the support. This concludes our presentation. Thank you.
I talked to you guys about this last week a little bit too, but can you comment on the reason why you chose the full parabolic design? And in your simulation, you can show one half that's nice, bright red color, and the back half that's blue.
Exactly.
You know, why are you incorporating that?
We were trying to maximize the surface area being affected at any one time on the sun. So if you can go back to the slide.
that's also, it doesn't have the cover.
Exactly. This is just the thermal power, that's the surface being directed directly from the sun is the red, and the temperature distribution as it steers away from the surface area.
So would you think that it's more important to have the most contact area in the base of the sun, or are you assuming that this enclosure as well can provide as much heat?
Exactly. Well, the enclosure is just going to supplement, obviously, the amount of surface area that we have, and also we have several different ways that we're going to. If we don't get the results that we expect, we can always modify the project, and like I said, we can put solar reflectors around it to maximize the area that's not directly in contact with the sun, as we have mentioned earlier with you.
Have you given any thought to safety? Because steam engines inherently are like blow up. Train engines have, Stanley Steamer blew up and killed people.
In general, we're going to be working with a relatively low steam pressure, around 15 to 20 psi, which is also an important consideration in choosing the steam engines that we're going to use. So the steam pressure will not be high, but of course we'll take safety precautions in terms of not getting burnt and dealing with the tubing as well to make sure there's no leakage.
Actually, my question has to do with the objectives. The objectives of your project. Because here in your report here, you mentioned two different objectives, and then you said your third objective, if time permits. So could you talk a little bit more about what your main objective is?
Yeah, the main
and
objective
what
is the design of the solar collector itself, and once we create the required steam pressure to be able to implement the other major components. But those components are not being designed; those will be able to purchase and implement into the system, and perhaps design the tubing itself that connect all the parts together. But the main focus is to design the solar collector to collect enough thermal energy to produce steam. That's our main focus.
Depending on the results that we get once we build the collector and we test it, we'll be able to build from that.
To put the whole system together.